All right, this is a quick review and geometric sequences. All right, so you have to keep the two straight. We had arithmetic sequences and now geometric. An arithmetic sequence had a common difference. A geometric sequence has a common what? And I hope you're thinking a common ratio. A common ratio. All right, well, here's an example of an explicit formula of a geometric sequence. Now, if you remember some things, you'll know some values right off the bat, but I'm going to lead you to them. So let's take a look at a couple things. What if I wanted a sub 1? What is the value of the first term? Well, I can get that by using the formula. So a sub 1 is negative 2 times 4 to the 1 minus 1. 1 minus 1 is 0. Anything to the 0 power is 1. Negative 2 times 1 is what? Negative 2. The first term is negative 2. And again, if you know the explicit formula, you know that it's a sub n equals a sub 1, the first term. So we know that that's right there. Okay? And let's also then, let's figure out r. Do you remember what r is? Well, again, if you know the formula, you understand that r is the common ratio, and it's right there. So the explicit formula is a sub n equals a sub 1, the first term, times r to the n minus 1 power. So therefore then r is what? It is 4. Okay, well, that's important. We know the common ratio is 4 between terms. Let's go ahead and do this next. Let's figure out the first 4 terms. All right, we already know a sub 1, correct? All right, so we need to figure out a sub 2. How would I do a sub 2? Again, I'm going to use my formula. Negative 2 times 4. What is n? N is a 2, right? So 2 minus 1. So now I end up with negative 2 times 4, or negative 8. Second term is negative 8. Let's do the third term. Negative 2 times 4 to the 3 minus 1. All right, 4 squared is 16. 16 times negative 2 is negative 32. Negative 32. And let's do the fourth term. So negative 2 times 4 to the 4 minus 1. Now remember, I'm following the order of operations here. So 4 squared is 16 times 4 is 64. 64 times negative 2 is negative 128. All right, so if I were to list the terms, I would list them negative 2, negative 8, negative 32, and negative 128. Now let me show you the r. What happens when you divide negative 8 by the previous term? What do you get? You get 4, don't you? Huh, cool. That was the common ratio. What do you get if you divide negative 32 by the previous term? Huh, you get 4. Cool. The common ratio. What happens if you divide negative 128 divided by negative 32? Guess what? You get, yes, you guessed it, 4, the common ratio. So you see how to do that? All right, so if they give you the set and say it's geometric, you can get the common ratio by taking, usually use the smaller numbers. I always take the second divided by the first. There's my common ratio. Cool. Only need to do it one time. R is R. All right, for all you pirates. And then finally, what if they said find a sub 8? All right, so I can find a sub 8. So I'm simply going to sub in. So I have negative 2 times 4 to the 8 minus 1. Got to use my calculator from here on out. And 4 to the 7th power. All right, so calculator out, 4 to the 7th. All right, big number, 4 to the 7th power. All right, 16,384 times negative 2, negative 32,768. All right, and that is the 8th term of this geometric sequence. Notice how quickly the numbers go up. And one other thought here, if you were to graph a geometric sequence, because this one's going in negative, it would look like this. Ones that go in positive would look like that. All right? Geometric sequence.